Assalamualaikum and hi everyone. So we are now in the final chapter in calculus, which is application of integration. Okay, so we will start with the first application which is area. Okay, and for this topic, I will split in two parts. Okay, so let's begin. So for this chapter, application of the integration, we have two applications actually. So we have the area of a region and also volume of the revolution. Okay, so we will discuss the first application, which is area of region. So at the end of this topic, you should be able to find the area of a region bounded by the curve, axis and also the lines. Second, to plot the graph to identify the region bounded by the two curves. And last is to find the area of the region between two curves. Okay, let's begin with area of a region. So in this section, we shall use definite integrals to obtain the area of a region bounded between a curve with either x-axis or y-axis and between two coordinates or two abscisses. Okay, we shall discuss area of a region under a curve, area between two curves about y-axis, and the last is area between two curves about y-axis. So for the first part, I will only consider and I will discuss with this topic, okay, which is area of a region under a curve. Alright, so the figure shows the region y equal to fx. Okay, so we have a function curve here, y equal to fx. Okay, the x-axis, okay, so this is the x-axis. Okay, and the lines x equal to a and x equal to b. So we have x equal to a over here. Okay, and this is x equal to b. Okay, so this region is located above the x-axis. So actually we will have this as the shaded region, and the area of this region is given by, okay, integral of fx dx. So we have fx, okay, this fx is the function here, the graph here. Okay, we integrate that function and put the limit from a to b. So we have this one is the limits. Okay, this is a to b. Okay, so this is the formula for area, right? So this is the formula for area, where we have area is equal to integral of fx dx from a to b. Okay, so the area bounded by the curve x equal to uy. Okay, so just now we have the graph where we have a function y equal to fx, right? Okay, so just now we have y equal to fx. So now we have curve which is x equal to uy, which means that we have a function in terms of y. So maybe this is the graph, this is the curve. Okay, so and we have the line y equal to c. So here y is always equal to c, and over here is y always equal to d. Okay, and we have the y-axis. So this will be the shaded region. Okay, so the area bounded by this graph also can be determined. Alright, so how are you going to find the area? It is by using this formula. Okay, just we have area, okay, is a function u in terms of y, okay, that you need to integrate with respect to y from c to d. Okay, so just now we have area equal to fx, and we integrate with respect to x from a to b. So this one is if you have a function in terms of x, but this one if you have a function in terms of y. Okay, right, so this is the difference between the first and second formula. Okay, let's look at example 1. Okay, find the area of the region bounded by the curve y equal to 2 minus x squared, the x-axis, and the lines x equal to 0 and x equal to 1. Okay, so the first step is to sketch the bounded region. So do you know how to sketch the graph for this function? Okay, we have y equal to 2 minus x squared. Right, let's recall. So if you have y equal to x squared, so the graph will looks like this, right? A happy, a smiley shape. Okay, but now if you have y equal to negative x squared, so what will happen to the graph? So it's very negative. Alright, but now you have y equal to 2 minus x squared. Okay, so which means that the vertex will be at 2, y equal to 2. Okay, so this is the graph of y equal to 2 minus x squared. Okay, and then you have the x-axis here, which means that, okay, we have this as the x-axis. Okay, it's bounded by the curve x-axis and the lines x equal to 0, x equal to 0 and x equal to 1. So x always equal to 0 is over here, right? So this is x equal to 0. Okay, x equal to 1. Where is x equal to 1? Is it here? You sure here? Okay. So how are you going to find this value? Okay, can you assume x? Can you simply assume that x equal to 1? So cannot actually. Okay, so what you can do is from this equation, so we have y equal to 2 minus x squared. So over here, okay, the value of x we do not know, but we know the value of y. So which is here, over here, you have y equal to 0. Okay, so you have 0 equal to 2 minus x squared. So x squared is equal to 2. So x is equal to plus minus square root of 2, right? So here, actually the value is square root of 2. Okay. But you have just now the x equal to 1. So x equal to 1 is smaller than x equal to 2. So you will have this one as a line x equal to 1. So therefore the shaded region is only over here. Okay, you have the curve and it's from 0 to 1 only. Okay, so this is the bounded region. So next is since you need the question asks you to find the area of the region, so we just use the formula just now. Okay, you'll have function which is y equal to 2 minus x squared. Okay, this is the function. You just use the function given. Okay, and the limits for x is from 0 to 1, right? So this integration you can solve directly. Okay, you can integrate directly, okay, where you will get integrate 2, you will get 2x. Integrate negative x squared, you will get negative x cubed over 3. Okay. Excuse me. And then just put the limits of integration 1 and 0. Okay, and then you'll get the answer, which is 1 2 over 3, 1 2 unit squared, since this is area. Okay, so this is the final answer. Right? Okay, clear? Okay, let's move to example number 2. Okay, find the area bounded by the lines y equal to 2 minus x, x equal to 3, x equal to 4, and x-axis. So again, the first step is to sketch the bounded region. Okay, so what you can do is draw the graph. Okay, 2 minus x. So 2 minus x, it's a negative slope, and you have 2 as y-intercept. So it's something like this. 6 1. So this is 2. Okay, so this is our graph. 2 minus x. Okay, so what is the value here? What is the value of x here? How are you going to get the answer there? Okay, we have again here, we do not know the x value, but we know the value of y. So which is y equal to 0. So we will have 0 equal to 2 minus x. So x is equal to 2. Right? So over here is 2. Okay, this is the graph. Right. So this is not the shaded region, because why? So we have y equal to 2 minus x. We have x equal to 3 and x equal to 4, which means that you can extend, okay, the x-axis here, and this is the graph 2, okay, where we have 2 over here, and we have just now x equal to 3 and x equal to 4. So 3 and 4 is greater than 2. So you will have somewhere here, this is 3 and this is 4. So we have this line. Sorry. So we have this line, which is we have x equal to 3 and this one is x equal to 4 to here. Okay, and another information we have is x-axis. So x-axis is, this is x-axis. So now the combination between the x-axis, the graph y equal to 2 minus x, x equal to 3 and x equal to 4. So the combination will be this. Okay, so this is the shaded region, or the area that we want to find. Okay, using the formula area just now, so you just use the information given from the question, where we have y, this is y, okay, y equal to 2x. So integrate with respect to x from 3 to 4. So if you see here, you will have what in terms of absolute value? Why do you think you have that modulus? Okay, because if you look at the shaded region, okay, the shaded region is below the x-axis, which means that you will get negative value. Okay, but since this is area, so area we will have a positive value, right? So that's why we just put it as absolute value, right? So you get negative 3 over 2, and we put it as a positive value, so we have 3 over 2 unit square as the answer for area. Okay, all right. So this is the exercise. So please do this exercise as your practice lah, okay, to enhance your understanding about this topic. Right, so till then, thank you.